Hey class, in today's lesson we're going to talk about the fundamental theorem of algebra, which is found in section 2.5 part 2. Our objectives are to find conjugate pairs of complex zeros and to find zeros of polynomials by factoring. So conjugate pairs, what we need to note is that two complex zeros are conjugates. They are of the form a plus bi and a minus bi as factors. And they may be written as x plus 3i or x minus 3i or x minus 1 plus 3i or x minus 1 minus 3i. The one part that I do want to point out, however, is that if we write them as the last two, however, we do need to distribute the negative. So this would actually be as one full factor, x minus 1 minus 3i, and the other one would be x minus 1 plus 3i. For example 4, finding a polynomial with given zeros. So we need to find a fourth degree polynomial with real coefficients that has -1, -1, and 3i as its zeros. The first two are fairly straightforward on how to write their factors, because in order to write a polynomial, the zeros that are given to us have to be written as factors and then multiply those factors to create the polynomial. But anyway, the x minus 1 is truly x plus 1. And again, x plus 1. If I have 3i, essentially that's x minus 3i. But remember, complex numbers always have a conjugate, so we would also include x plus 3i. All right, so some function, some fourth degree polynomial will be these four sets of factors multiplied together. So we're going to start with these two. If I multiply those two, and I could use the box to show it, we would get x squared plus 2x plus 1. With the last one, x plus 3i and x minus 3i, I will show a box just so that you can get a better feel of it. Again, x times x is x squared. X times 3i is 3xi. X times negative 3i is negative 3xi. Negative 3 times positive 3 is negative 9i squared. Okay, the xi's will cancel. And the negative 9i squared, understand that I squared is negative 1, so it's negative 9 times negative 1, which gives us positive 9. In the end, that box only equals x squared plus 9. Okay, now we have a trinomial times a binomial, so we'll go ahead and use another box to finish this problem. Again, this is a 2 by 3, so we'll have x squared and 9 out to the side, and then I have x squared, 2x, and 1. All right, that'll give me x to the fourth, 9x squared, 2x cubed, 18x, x squared, and 9. In the end, our answer will be x to the fourth plus 2x cubed. We have 2x squared. We have a 9x squared and an x squared, so that's going to make plus 10x squared plus 18x plus 9. And that's our fourth degree polynomial. And we are done. Let's take a look at our next problem. In example 5, we are asked to write the polynomial f of x equals x to the fourth minus x squared minus 20 in factored form. On this one, we can't necessarily just kind of start the problem. I mean, we could, with a graphing calculator, kind of get an idea of some of these zeros. But what you're going to find is that these zeros are not whole numbers. We'll get some really terrible decimals. And specifically, they want us to find all of the factors. So we will do a different procedure. We're going to use substitution. So what we're about to do is a substitution method. In other words, my highest power is x to the fourth, but I want to force it to become an x squared. So to do that, I have to use the variable a and say that anytime I see a, it's going to be x squared. So as an example, x to the fourth is really x squared squared minus x squared, then minus 20. So now every time I see an x squared, it's now a. So this is a squared minus a minus 20. At this point, I can use AC. AC would give us negative 20. The factors of negative 20 that work are negative 5 and positive 4. So that would be a minus 5 and a plus 4. All right, that's as far as we can go with factoring that way. So now we will substitute in x squared. So that'd be x squared minus 5 and x squared plus 4. If I set these two equal to 0, we would add 5 to both sides. X squared equals 5. Take the square root. So x equals plus or minus the square root of 5. On the other one, if I subtract 4, I would get x squared equal to negative 4. Take the square root, and x equals, because of the negative, it's I, so it's plus or minus 2i. Now to write this in factored form, our final answer will be, and I'll switch colors just so we can see, f of x equals, if I want to write the 0 positive square root of 5 as a factor, it's actually x minus the square root of 5. To write negative square root of 5 as a factor, that'd be x plus the square root of 5. To write 2i as a factor, that'd be x minus 2i. And to write to write negative 2i as a factor, that'd be x plus 2i. So this is our answer. All right, our last example. Example 6 says finding the zeros of a polynomial function. So to find all the zeros of f of x equals x to the 4th minus 3x cubed plus 6x squared plus 2x minus 60, given that 1 plus 3i is a 0 of f. All right, so first of all, what we want to do to narrow this down is to check for zeros on our graphing calculator. So if we were to type this function in on our graphing calculator, what we would see, so I'm going to say check graphing calculator. Oops, not GG, but GC. We will get the zeros x equals negative 2 and x equals 3. Okay, so to get this from a 4th power down to a 1st power or a 2nd power, we'll use synthetic division to break it down. So I should be able to use negative 2. And we will get, in order of our powers, and all of these are in order, there are no gaps. That's 1, negative 3, 6, 2, and negative 60. That's negative 2, negative 5, 10, 16, negative 32, and negative 30. And then 60 and 0. That's what we expected. Now we're going to take this 3 to break down those numbers. So 1, negative 5, 16, and negative 30. We'll get 3, negative 2, negative 6 and 10, 30 and 0. And again, that's what we expected. So this is a quadratic equation, and what we'll have left over is x squared minus 2x plus 10 equal to 0. Now we can't use AC for this one. It simply just won't work. So what we're going to do is we're going to switch up and we're going to use the quadratic formula to find the rest. So we have x equal to negative b, which is negative 2, plus or minus the square root of b squared, which is negative 2 squared, minus 4 times a, which is 1, times c, which is 10, all over 2 times 1. That will give us 2 plus or minus the square root of 4 minus 40 over 2, which is 2 plus or minus the square root of negative 31 over 2. Oh, it's not 31, it's 36. Sorry, let me go back. Okay, that's negative 36 over 2. That negative needs to come out of the radical, so it's going to be 2 plus or minus 6i over 2. And when you divide all that by 2, you get, as your final answers, 2 plus, not 2, but 2 divided by 2 is 1, plus or minus 6i divided by 2 is 3i. So here are the final two. So we already knew that one of the zeros was going to be 1 plus 3i, but we just also found out that the other is 1 minus 3i. Now, another way of doing this, and so let me go ahead and say that from the graphing calculator, we found negative 2 and positive 3, but we just found that also 1 plus 3i, we already knew that, and 1 minus 3i, are the other zeros. Another way of doing this would be to start with 1 plus 3i, knowing that the conjugate is 1 minus 3i, multiplying those two together to get our answer. So let's take a look and see what that would give us. So let's see. I'm just going to erase this and we'll get the same answer. So let's just take a look. There are two ways of doing that. So the first way I showed you was the easier way with the graphing calculator, okay? All right, so let's say we don't have a graphing calculator. Again, 1 plus 3i is a factor, so that's x minus 1 plus 3i. So that means that the other one is x minus 1 minus 3i. So let's see these as factors. So if I have x minus 1 plus 3i, if I distribute that negative, this becomes x minus 1 minus 3i. If I have x minus 1 minus 3i, again distributing that negative, that would give me x minus 1 plus 3i. So I will take these two and multiply them. So it's going to be 3 by 3. A little tiny, but sorry. X, negative 1, negative 3i. X, negative 1, and positive 3i. So this is x squared minus x, 3xi. This is negative x, 1, and negative 3i. This is negative 3xi, 3i, and negative 9i squared. Now, what we should notice is that 3xi and negative 3xi will cancel. Negative 3i and positive 3i will cancel. And then this negative 9i squared is really negative 9 times negative 1, which is really positive 9. So when we take everything out, you're really left with x squared minus 2x plus 10. Now, we can then use this polynomial and divide it out with x to the fourth minus 3x cubed plus 6x squared plus 2x minus 60. So I'm going to write x squared minus 2x plus 10 on the outside. And I have x to the fourth minus 3x cubed plus 6x squared plus 2x minus 60. All right, focusing on x squared and x to the fourth, that's going to leave me with x squared. X squared times x squared is x to the fourth minus 2x cubed plus 10x squared. Remember, we change our signs. We're going to be left with negative x cubed. That was a negative, so minus 4x squared. And then bring down your 2x, so plus 2x. Start over. X squared and negative x cubed will give you negative x. Multiply, that's going to give you negative x cubed, positive 2x, and negative 10x. Change your signs. That leaves you with negative, that was squared, negative 6x squared plus 12x, and then I drop down negative 60. Now I focus on x squared and negative 6x squared, so that's negative 6. And that should give me negative 6x squared, positive 12x, and negative 60. Again, all the signs change, and then this time everything cancels. So we have this polynomial x squared minus x minus 6. So to find my other two factors, knowing that from the beginning, since I had 1 plus 3i as a 0, I knew that my other 0 is 1 minus 3i. If I take what I just found, this x squared plus x minus 6, or minus x minus 6, and I factor that, AC will be negative 6, and the only factors that work are negative 3 and positive 2. So I would have x minus 3 and x plus 2. And again, that lets me know that their zeros are x equals 3 and negative 2. So in total, all of my zeros are 3, negative 2, 1 plus 3i, which they told us, and 1 minus 3i, which is what we knew based off of them being conjugates of one another. Again, the first way was a lot easier, a lot simpler. That's if you have a graphing calculator. If you do not have a graphing calculator, you would have to go this route. So, anywho, if there are any questions, please come see me for tutoring.